Yeah, to apply a mathematical approach, can you use a pencil and paper?
Yes, yes, yes.
Can you use a hand calculator?
No. Well, let me back up. This is all done with pencil and paper. The analysis of the Zhang-Rui game was computer assisted, and we spent quite a while developing programs to assist.
On my first day as a postdoc at Bell Labs, theoretical physics group, they said there's just two things that you have to worry about: playing Go at lunch and making sure that you're there at tea. That's when we talk about physics.
I learned Go. The first time I'd ever seen a Go game was at Bell Labs when I was there as a summer student at the age of 19. Yes, which is one reason I never got terribly good. You got to start at 8 or 9, like Go Sagan, if you want to get really good.
Has there been any success in somehow looking at the patterns of what the masters are doing early in the game?
Don't have a direct answer. The computer Go field, which I'll comment on, right now there's about, which I'm not into, but there's about 50 groups around the world doing computer Go. And they range from 6 or 7 people to sometimes 1 or 2. They compete with each other against other computer Go programs a couple times a year. There are 2 big tournaments. There's the Ing International Tournament, and then there's the Frost Cup, which is Japanese. And, you know, positions jostle around and change a little bit. But they seem to be stuck at about a 5Q level. I don't know how you understand the rankings. I'm a couple stones better than that. I mean, I can give most of these programs a couple stones and probably beat them. There's well over 1 million players in the world who can always beat me. So this is not that good, although they will beat a beginner and they give you some kind of game to play against. But the focus is on the programs playing each other, which gives them a real game. And some of them have tried all kinds of things. I mean, some of them try to talk to masters. The current world champion, and he's won like 3 years out of the last 5, is a Chinese program called Hand Talk. And the guy, the leader of that team, is a retired high school teacher who, in addition to teaching some science, I think chemistry actually, ran the local Go club and taught lots of beginners how to play Go. Including several of his former students became professionals. So he's a great Go teacher at an elementary level, and he's sort of managed to build enough of that into his program that his program is slightly better than many of the others. But trying to conversations with, I've had many conversations with Zhuzhou and Naiwei and others. I mean, once we started giving them problems they couldn't solve, it's not hard for me to get attention from Go masters anymore. But it's very awkward. I mean, you'll find out, you know, see, they don't want to learn any theory. I mean, they'll try and do this with traditional methods. And they'll say, oh, no, this move has, well, it doesn't, it has, they have many more adjectives in front of Sente and Gote to try to sort this out. And it's a methodology that doesn't work. I mean, there's no way to linearly rank order these things. You've got to add them all up. I mean, but what they're doing is something that will work, you know, 70, 80% of the time or more in the cases that they're most likely to encounter. And that's, their real goal in life is to win. They're very much like, they're very competitive. Their behavior, both the computer Go club or gang and the professional gang, remind me in some ways of football coaches. I mean, when you visit Zhuzhou Naiwei, what is she doing? Most of the time she's studying games played by her next opponent. I mean, just, you know, like, what does the coach do? He gets out the tape of yesterday's game of whoever's going to play next week, right? You know, where's their weak spots? How can we modify our style to fight this, you know? And so it's very individual specific. And I want winning moves. I mean, I don't want moves that depend on who I'm playing against. And it's a mathematical view rather than a competitive view.
Is there evidence in history that expertise at Go leads you to be either a great military leader or a great country political leader or anything like that?
Legends are abundant, and you know, see, you're dealing with a culture where you're not going to get in the history the kind of, you know, sociological data that would stand up to any sociologist here, for instance. I mean, so I don't know how you measure that, but certainly there are tales and stories. I have many famous tales and legends, and some no doubt true, one of the most famous ones I just mentioned is in medieval times, there were these two Japanese clans that were at war, and they were ready to, with their samurai and all, to go slaying each other off. And some peacemaker came along and said, nope, why don't we sell this with a game of Go? See? And so they agreed. And then each put one Go player out, and they played a game of Go. And this particular game of Go ended in a so-called triple Ko, which is a very strange situation, where the game is essentially hung in, what I would say, hung in a loop. I mean, the Ko rule attempts to ban that, see, but it doesn't ban these more complicated loops, which give rise. So the game ended in this hung situation, right? Now, and there's no Japanese rule forbidding that, so the game ended in a hung outcome. And so they went home for the night, wondering what to do. Meanwhile, one side jumped the gun and assassinated all the other, okay? Now, and they were slaughtered that night. Now, the losing side, however, their allies later won the war. So it's their version of history, which is now predominant. And the conclusion is that a triple Ko is an extremely bad omen. See? So this has crept into the rules, okay? If this happens, for instance, it's not treated as a tie. It's treated as though both players lose, okay? I mean, it's very, to a Westerner, very, very strange, but that's the way it is.
Among the deans in LNS, we've had some conversations about strategies for getting young people to go into the mathematical sciences. And I'm wondering whether it's your intuition that the 8 or 9-year-old being exposed to something like Go is going to have his or her passion engaged in a way that will in turn stimulate them to become much more mathematically competent. Any intuition?
Well, personally, let me just say, in the first grade, okay, I don't know how I learned anything, but I already knew how to count to 100. I already knew how to add two-digit numbers. That was the arithmetic curriculum. I had a friend who, likewise, was well ahead of the class. The teacher kindly let us sit in the back of the room and play the game of dots and boxes, okay, which we did at great length. And as long as we didn't disturb anybody, and whenever she interrupted and asked us a question, we would pop in with usually the right answer. She was very tolerant. And yes, I believe that, games has been constructive. Whether traditional Go is the right game, I'm somewhat skeptical. I think there are a lot of easier games, which you do lead, even just teaching kids to play NIM, for instance. I mean, this has got binary number system, a lot of things in it. And I certainly favor that. I run around and give talks. I gave one in San Jose to junior high school kids just a couple nights ago. And, how big a success this is, who knows? I mean, to get a few enthusiasts like me getting kids interested is not so hard. I mean, to do this on a wider scale is iffy.
The magnitude of the handicap against the player who goes first should depend on the relative strengths of the two players. So how is that determined?
Back to the handicap issue in general, this so-called Komi, see. Mr. Eng, who is the tycoon who put up most of the money for the Eng Foundation, also wrote a book on rules. And his preface of the book on rules says, it is the right of the sponsors of the tournament to define the rules of competition and the duty of the players to abide by them. See? So there's a power struggle, contentious issue over who sets the Komi. See? And so you have disputes where even just a couple decades ago, Japanese players would decide to refuse to play in a tournament in Taiwan or Korea or somewhere because the Komi was wrong. See? They then thought the Komi should be 5.5, and for a while the Chinese thought it should be 7.5. See? Okay? Trivial solution. I mean, you set the Komi at 6.5 and put each on a side where he thinks he has an advantage, right? But no, that would be a Western, solution. It is the right of the tournament directors to not only say who plays black and who plays white, but what is the Komi. See, so that's the way it's stuck. There is the handicap system in Go, and what it does is the weaker player gets so many stones head start. See, and that's graded all the way down. When I say my rank is right now, it's about 2Q, which is -2 in some sense. You start at -infinity and you work up to the smallest master rank is 1 Dan. So you go Q, 10Q, 9Q, 8Q, 7Q. Each of these ranks is worth about 1 stone. So if I play some guy who's like 2 or 3 dons, see, he will give me 3 or 4 stones head start. See? But the Comey is not, the Comey is a finer structure. The stones are worth about 13, 14 points. Jujo and Naiwei there were arguing whether it's 14.5 or 15. Theoretically, if the coupons were infinitely spaced, the Comey should be worth half the value of the top coupon. So when they're taking a 14.5 point coupon, what they're saying is they think the fair Comey is about 7.25. Now, Japan just a couple years ago finally changed, based on massive statistics, that with a 5.5 point Comey, black was still winning 53 or 54% of the time, and so they changed it, and it's now 6.5. But that was just a couple years ago. Most in Taiwan are still winning 7.5. So I mean, it's all.
It sounds like computer programs have been far more successful at chess than Go. Is that
Yes.
the relative difficulty or the relative resources put into?
Well, that's a Western DARPA-style view, that yes, we had a lot of resources. My own view is that the paradigm that is used to play checkers and chess, and maybe Othello, is unique to checkers, chess, and Othello. I don't believe you can write a great program to play dots and boxes like an expert, or many of these things. See, the reason it works is that in chess and checkers, the kibitzer is sitting there looking at the game between 2 pros. He can count, you know. I mean, he knows a little. He knows, yeah, gee, white's captured a rook and black got only a knight in return. So he does this calculation. Gee, it looks like that player's 2 points, two pawns ahead or something. And so he believes that that's an advantage, right? 90% of the time he's right. And in fact, unless something pretty big happens fairly soon, like a capture or some checks start happening, unless there's some activity pretty soon, very likely this 1 point advantage will turn into a win. So you have this crude estimate just based on material, which is close enough to the reality that when you minimax it back 5, 6, 7, 8 moves or whatever, and that's where the computer power and clever programming come in, you're converging to something that's pretty good most of the time. See, in Go, the kibitzer usually has no idea what's going on. He sees, you know, these. Let's go back to one of these positions we had here. Yeah, that's this one. That's a good one. I mean, you listen to Go masters discuss this. Oh, yeah, black has strong influence in here. White has some influence here. You know, I mean, as this kind of talk, and you know, yeah, gee, this move is going to force them out there. I mean, you know, and try to quantify any of this. You know, I mean, how many points is black, you know, likely does this influence get him in here? You never get an answer, and the kibitzers have no idea. So the programs try to estimate these things in various ways. These estimates are pretty poor. So minimaxing back 20, 30, 40 moves is nowhere near enough to get convergence. I also might say, while I'm on this topic briefly, that the success of computers in both chess and checkers has been wildly hyped by the interests supporting them. IBM marketing is very adept and has persuaded the world that computers have solved the game of chess or something, and it's nowhere near true. I mean, I don't know any knowledgeable insiders who believe that when Big Blue defeated Kasparov, that if the next day it had started playing against Anand or some other major chess master, extremely likely the chess master would beat it. I mean, I think everybody would be betting on the chess master stuff. That's not because in the competitive level these things are very opponent specific. And Big Blue had among its team a very serious chess master who had studied all the games of Kasparov and wrote all that in. They were also very secretive and would not let Kasparov see any game that had been played by Big Blue, for instance. So that's problem one. Problem two, Kasparov did make a very bad blunder in one game, so much so that the real economic skeptics among us observe that this is a situation where bribery would be very easy. I mean, well, stop and think. As is true with Ing. I mean, it's a strange thing. See, the human doesn't get the kid doesn't get anything much for. I mean, he gets $25,000 for beating the computer. See, the computer wins, the computer gets $1 million, right? So why didn't the computer bribe the kid? I mean, okay. No, it's very hard. I mean, in Asian culture, it's very hard. You got to get to his parents. I mean, it's going to be. But It's probably very hard to write Kasparov too. I'm not suggesting it happened, but I am suggesting that the advantage that IBM winning that it was run by the marketing department is almost surely $10 million or more was their benefit. And of course, as soon as they did, they dismantled the machine and took it down before anybody could challenge it and question. Well, that's exactly what they did. Yes, Big Blue doesn't exist anymore. I mean, so it's how many people think computers are anywhere near solving checkers? For instance, most people think, oh yeah, long ago. False. There's a book by Jonathan Schaefer. Humans are still beating computers at checkers. I mean, and the best checker program was written by Jonathan Schaefer. Now, not very many, but it's still a big achievement. I don't want to totally degrade these computer programs. They are playing at a level where there's only maybe, in both chess and checkers, the order of a dozen of the world's best players who can compete with them. So, I mean, that's still awfully, awfully good. But it's not to say they've gone on to some higher rank yet above everybody. No. They're up there in the top league. That's correct.
Could you say more about the differences between the ways the game is played today in different parts of Asia?
For a while we had Kansai Keen rules, which was Osaka, and Nihon Keen rules, which was Tokyo, and they didn't totally agree, see. And we got rules in China, we got Ing rules, we got Formosan rules, we had New Zealand rules, we have U.S. rules, and they all differ in teeny microscopic details. Less than 1/10 of 1% of the games will these differences matter, see. But all the Asian rules begin with the same premise, that statement one, the rules committee is so-and-so and so-and-so and so-and-so. 2, all disputes will be resolved by them. 3, sort of like our Supreme Court. They will resolve these disputes in accordance with the long history and tradition of the way they've resolved all disputes in the past, see. Okay, now you look at what is the code of decisions they made in the past, and it's chaos. I mean, basically, they tend to favor whichever player they like more. I mean, that's the cynical view of this. And then once in a while they try and racialize, and so you see, it is only America and New Zealand, and now Europe, who have rules committees which will entertain academic discussion. The Chinese rules, by the way, are clean with respect to scoring and a mess with respect to this whole business of loops. If you get into a complicated multi-code, multi-situational loop, the Japanese, very clearly, it's just a hung game. Not clear what hung means, but it's like a hung jury. You go back to the judge and argue again, see. Maybe you replay, maybe you cancel it or something, but I mean, it's that kind of outcome. In the West, both America and New Zealand have a simple rule that you're not allowed to repeat any previous board position, so there is no loops. I mean, that gets rid of them all. But the Chinese and the Taiwanese and these others, they all believe that in this kind of a loop, it's white who's not allowed to repeat the position, and black has to do something different. But in this kind of loop, it's the other way around. And then all those are done by examples that are sort of chaos. See? Now, Ing, in his rules, claimed, he's really gotten rid of ties by specifying all these things. So he offers this prize, I think it was $50,000, to any mathematician who can prove that the Ing rules will never result in a tie. See? So this is floating around. Some very clever people at Oxford come up with what, to the view of most of us, is a counterexample of a very complicated construction, running trains all around the board. And this is not resolved by the Ing rules, basically. Okay. So this gets submitted to the Ing Foundation about a year after Ing's died. The foundation, of course, doesn't want to embarrass their great sponsor and all. And the prize was not to be awarded for someone who found a counterexample or disproved it. So the prize is still there. And lawyers read and they interpret it, well, these English people didn't really interpret the rules properly, and it's all done in erudite Chinese prose, and so nobody really knows quite what the Ing rules are.
You said that both in checkers and in chess, the computer programs are up in the top league, but not better than humans. Do you expect that to be a stable situation, or how long?
Oh, I don't know. Hard to tell. The amount of effort going in there right now is certainly, I mean, there's much more effort in computer Go than there is in computer chess and computer checkers, because computer checkers, it sort of reached its peak in popularity. I think it'll come back. I mean, I see computer scientists and mathematicians in this area, have different philosophies, and in this particular area, I'm very much a mathematician. I mean, I want to find good moves and statements that are provably true. Like, I want to say, gee, this is the position we've solved, and white can win, and yeah, here's an enormously complicated tree, but we've got it all worked out, see, somehow or other. artificial intelligence buffs believe that the main purpose of playing these games is to develop system program expertise, which is great for training students. They become good at, writing programs, which is sort of a skill that they believe will be useful in other endeavors. Somewhat true, I suppose. It's good practice. I don't know. But they really want a program which, in a situation like this, will make some kind of decision and make some kind of move. See, I'm quite willing to just say, gee, this problem's so complicated. I don't think in my lifetime we're going to get an understanding of this.
Question from cognitive psychology. Is your decompositional method available to players without any external aids like pencil and paper?
Well, I was going to answer that before. This one, yes, this is totally pencil and paper. This one, up here in the north, the situation is beyond what you can do with pencil and paper, and there was a lot of effort in this region here. We continue to try and improve our methods. I mean, one people asked, gee, why haven't you just programmed everything in? Well, we have some programs that are aids, but when we start working on almost every problem we work on, we find some more tweaks. I mean, see, even breaking the board up into regions is sort of tricky, and it doesn't really break. I mean, right here, there's some risk that after black plays here and white ignores it, black gets around into this corner, and this whole region gets much bigger and runs away. And, you end up with a certain amount of judgment or statements about that not being allowed or whatever, And then so the question of how well the model really applies to the particular situation is an area that gets a little gray in some cases. How big are these regions? And also, we allow interactions between regions now, but what I call federations, which are sort of a weak kind of alliance like you have in Canada, as opposed to a federal structure you have here.
So in a real world application, you would want to make sure that in some situations people are not allowed to make decisions on the basis of intuition, because intuition is bound to fail.
I don't know that. I mean, when you're in that situation, it may be that everything's bound to fail. I mean, mathematicians by and large are hunting for perfection of a level that may just not be attainable. I mean, you may need to make some decision. I mean, we all make decisions, right? We decide which of two offers a job to take or whatever, right? And there's no way to algorithmize this. Just like here, you got to make some kind of decision, so you do something, right? I mean,
if solving the problem is having something sensible and solid to say from start to finish, how does the complexity of that problem grow with the size of the board? So, a 2 by 2, I'm sure you can do 19 by 19. How is that difficult?
There are people who've done that. That's another pursuit I'm not into. There seems to be consensus among experts on what ought to happen in the 9 by 9 board now. Doesn't mean it's right, though. I'm somewhat skeptical, but I think experts in a lot of fields end up with a consensus that they all know each other, they all talk to each other. After a while, they all think alike. No, they're right. They're right probably 70, 80% of the time, but they usually are arrogant enough to believe they're right, 99% of the time. Just to give you one example in chess, Ken Thompson, who is my student who invented Unix, also wrote the program called Bell at Bell Labs back in the mid-'80s, which was then the world's chess champion among computer programs. And he was very much into this. He was also very much into chess endgames, and so he started just cleverly brute force exhaustive search of endgame positions, and he solved them for 5 men, got various new results and all. And then another guy named Louis Stiller came along and pushed this up to 6. And he got supercomputers and more algorithms. But the history of the way that evolved with the chess community, see, when Ken found that there were various positions that you could win, but it took more than 50 moves. There was a classical chess rule that says if 50 moves pass and no piece has been captured, and then the game is a draw to stop endless draws, right? Ken found some where you could win in 70 and 80 moves, right? So they changed the rule, went up to 100, right? Stiller came along, and just in the case of king plus rook plus queen versus king plus rook plus queen, so you got 3 on each side. Each side is a king, queen, rook, right? These 6 pieces, and they go and fight it out. Nearly all chess masters, in fact, I'd say 100% chess masters believed that unless one side or the other could do something like capture peace within the next 10 or 15 moves, which is the depth they could think ahead, that surely this position was going to be a draw, right? Totally wrong. Turns out 80% of them, and most of them are that type, turns out 80% of them, he searched them all, is a win for somebody or other. The longest one takes 240-some moves, okay? You play this out. When he gives a talk, he puts this on the background and he just talks, and you see these pieces wandering around. This is the shortest win from that position, okay? So when they heard this, what do you think the Go Federation did? They said, oh, this is too complicated. We're changing the rule back to 50, which is what they did. That's exactly what happened. That's what, and chess masters, you know, have trouble digesting that, yes, they all believe that all these positions were draws. And no, very few of them are draws. I mean, you know. So, what can you say? I mean.
Thank you very much.